Hi there and welcome to lesson 3 in our C3 chemical economics topic. Now today we are going to be looking at rates of reaction, and this is our third lesson on rates of reaction. We're going to be focusing on a couple of other factors that can affect the speed and the rate of a reaction. Anyway, I will see you at the end. Bye bye. Okay, so our objectives for today's lesson is by the end of the lesson we should know and understand how the rate of a reaction can change when you react a solid or we use a catalyst. Now, when you have a solid reactant such as marble chips or other solids, then magnesium ribbon perhaps, then you can change the rate of the reaction by the size of the lumps that you use. Now what we're going to look at is how that actually affects the rate of the reaction. Now on the screen here we've got a solid reactant. Now if we're going to react this with a solution or a gas, then we've got here our reactants. Now what they can all do is they can come in and they can react at various different points. So we start our reaction. Now if we were to just move those to one side, if we were to break these lumps up, we've got more surface area on these solids where they can interact with our reactants. So what we're going to have is, if we have smaller pieces, then we're going to have a faster reaction, and that's purely because the surface area, so the area along here on these smaller bits, is greater than it is on the larger bits. So the bigger the surface area, the faster the rate. Now if you have a gas reactant or a dust reactant, now obviously dust, which is solid, is going to have a very, very large surface area. Because they're very, very fine particles, it can obviously cause a very, very quick reaction. Now as we said in earlier lessons, if we have a very, very fast reaction, we can experience things like explosions. So we can get explosions when we have custard powder, or if we're burning hydrogen, which we get a very, very big explosion. Now because of that we get huge volumes of gas, which means we get a big distribution of all the particles. So here we've got a hydrogen bomb, and you can see that just from that small little area we've got a massive release of gas, and that's where we get these giant mushroom clouds. Now the same things for other materials such as dynamite and TNT. Now we do need to be aware of various different situations where there could be flammable materials. Now with the production of some materials such as custard, now custard is a very flammable material. It is mainly sugar that's in there, but it's very flammable, and because it's a very fine powder, when you producing custard powder, a very small spark can ignite a big explosion. Now the same in the manufacture of sulfur and in the production of flour as well. Now a catalyst is a chemical that you can add to a reaction and it will remain unchanged at the end of the reaction. Now what the catalyst can actually do is it can either speed up a reaction or it can start a reaction. Now, catalysts are often solids, and as we've just spoken about, having a large surface area can make a catalyst more effective. And that's because you've got more particles exposed and you've got a greater chance of a collision, and therefore we have that key term again, a more frequent successful collision. Now, a catalysts are quite often the transition metals, which are the elements between group 2 and group 3. So from elements from scandium to zinc, which makes things like iron, nickel, chromium, they are all very, very good catalysts. Now, if we have a look at a set of data, we can see from the graph that we're going to look at here that if we have a reaction where we're producing a volume of oxygen, such as decomposition of hydrogen peroxide, then it will decompose on its own, and it will be able to produce a certain volume of gas. Now, if we were to change that and add a catalyst, now you can add several different types of catalysts. The best one that you can use is manganese 4 oxide. Now, what the manganese 4 oxide will do is it will increase the initial rate. So what it will do is it will make it faster at the beginning, and then eventually it will slow down as the reaction comes to an end. Now, what you can see here is the rate here, because we've got that steeper graph, so we've got more oxygen being given off in a shorter time, we have a much quicker rate. So the steeper the line, the quicker the rate, as we've done in previous lessons. So just adding that catalyst can mean that we get a quicker reaction. Okay, so to review our lesson today, we have looked at how increasing the surface area of a solid reactant can make the reaction go a lot quicker, and also if you add a catalyst to a reaction, we also get a initial speeding up of that reaction. Now, if you combine the two, if you have solid catalysts, then you can increase the surface area of those. You're going to get a much bigger or much quicker reaction, and that's actually what they do with catalytic converters. They use honeycomb shapes in catalytic converters to increase that surface area so that you get a much quicker reaction in getting rid of those deadly gases, I guess. Anyway, I hope you've enjoyed this lesson, and I will see you next time. Take care, bye-bye.